Hello everybody, you're very welcome into this video. This is Sean here from SMD Methods. In this video I'm going to set out a solution for the task C, the PLC task of the 2024 regional qualifier of the automation discipline of WorldSkills UK. That task is laid out on this document here, which is a copy of the brief for that competition. 2024 task A was a pneumatic sequence. Task B was an electro-pneumatic sequence, and indeed task C is our PLC sequence, our PLC task. We can see in 2024 there was 3 individual sequences that needed to be coded. Each sequence needed to be executed following the depression or the pressing of a specific button attributed to it. And we could see there that in each sequence we're running a counter. So just to emulate what would happen in these competitions, we'll take a very quick run through this task, and what we'll do is we'll talk about a couple of specific points as they crop up. So when the judge is reading these tasks, you can mentally organize how you're going to go about coding your solution. We are going to be using the template that I created over a number of videos in this playlist on the ET200 PLC. So having in mind what my tagging structure was, what provisions I've had in my template, or what I included in my template, I'm going to know how I'm going to tackle this, or I'll get used to it with practice. And of course, training is a necessary prerequisite to the preparations for entering into these competitions. And a lot of that training is familiarization with your PLC template whenever you are focusing on the PLC elements of the competition. So I'm using TP 101 and 201, which is standard enough in the regional qualifiers. Now, in last year's regional qualifiers, there was additional equipment given to the competitors in the lines of switches that needed to be DIN rail mounted, lights as well that were mounted onto custom stands, which were also DIN rail mounted, and they're also hardwired. So don't be shocked to see that in 2026 either. And forward, that'll not just be TP 101 and 201, but there'll also be additional hardware given as well. But however, we have 3 sequences which are laid out by this L1 plus. We could see there that the plus signifies energizing of L1, and of course L1, L2 and L3 are lights, and these are the lights that are found on the momentary push buttons that are on the EduTrainer button box, which is 4 buttons. First one, PB1 being a dedent, and then PB2, second one PB3, the third one PB4, all being momentary switches. So the lights of L1, L2 and L3 belong to PB2, PB3, PB4, the momentary switches. So I'm going to assume the sequence 1 is going to run off the first PB that's momentary, which is PB2. So light for PB2, and I'm going straight into a counter function. And in the counter, I'm going to execute this routine twice, and then the light goes off. Similarly with sequence 2, it's going to run on the depression of PB3. The light in PB3 comes on. I'm going to run this subroutine in this counter sequence here 3 times, A plus 2 seconds A minus, A plus 2 seconds A minus, and A plus 2 seconds A minus. And then the light goes off, and then sequence 3 being started by the depression momentarily of PB4. I'm going to turn on the button or the light of the PB4 push button for executing this routine, B plus B minus 2 seconds, doing that 3 times, turn the light off. Additional circuit requirements, the pressures of 5.5 bar, that's okay. Whoever's building is going to make sure that's been looked after. The main power to the circuit is provided by actuate and retentive push buttons, which is our PB1. This will enable the subsequent momentary switches that will be used to execute each of the sequences above. So in other words, we should not be able to execute any of these sequences. In fact, PB2, PB3 and PB4 should not work unless PB1 is depressed. Once activated, the power or the light and the power on button should also illuminate it. So if I have PB1 depressed, its light should be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should be on. — assuming there, if I don't have it depressed, its light should be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should not be on. — assuming there, if I don't have it depressed, its light should To execute a particular sequence, its associated momentary switch must be pressed for a minimum of 3 seconds. So to execute sequence 1, the associated memory switch, assuming that it is PB2, must be held in for 3 seconds before sequence 1 comes on. Once 3 seconds has elapsed, the light will then come on, so signifying there that we are now executing the sequence, and then it stays on till it's completed, which is also illustrated here by the minus at the end of the sequence, and that's going to be the same for all 3 sequences. Now we use a solenoid actuated spring return valve for cylinder A and a double solenoid for B. This is very important if you are new to automation or mechatronics indeed. If a cylinder is single acting or double acting, it does not ever matter in PLCs or electro-pneumatics. So when I say single acting cylinder, I mean a spring return cylinder. So if you have a pressure extended, pressure retracted cylinder, or double acting cylinder, air pressure that is pneumatically driven, double acting cylinder, you know, people seem to be an awful lot more comfortable with them because you seem to be, you do have more control over them, or so you think. You don't really. It's not the cylinder you're controlling, it's the valve you're controlling. The valve is connected to the cylinder. So you need to ask yourself, is it the valve that is spring return or single acting, if you like, or is it the cylinder? It doesn't matter if it's the cylinder. A and B are double acting cylinders. That's just a hardware choice, and in fact, it's an efficiency choice, and it's a function of what the cylinder's doing. Okay, so the cylinder has no load on its retraction. There's no point really retracting it using air. It's kind of it's an inefficient way of doing it. However, we see here that cylinder A has to use a solenoid actuated spring return DCV. That's the important bit. We need to always think about the DCVs, the directional control valves. We have a double solenoid for B. So that means when A extends, we need to provide power to the 14th solenoid of the directional control valve, but we need to maintain power onto that for the length that A remains in extension to stop the spring driving A back too early if we let go of if we de-energize that solenoid. So we need to maintain energy onto that solenoid for the length of the extension of A, which means we need to hold A on through all this here, and then we only let de-energize A here. Same here, A gets held on in energization here, and we don't need to worry about in sequence 3 as there is no A in sequence 3. Each sensor is to have a sensor to detect its extended and retracted position, so we are going to use assuming LOA, L1A, LOB, and L1B, which are my limit at my two ends, my limits of my cylinder, extended and retracted. A has magnetic proximity sensors, which is given here, and B's position is determined by any of the other available proximities. So that's for your builder to decide. From a coding perspective, it doesn't really matter. From a building perspective, it does matter. And the output from the magnetic proximity switches can be directly connected to the PLC inputs, which is fine. And we're also going to assume there that, well, it doesn't matter from a coding perspective. We're only going to indicate what solenoid should be energized. How they get energized is really down to what the circuit requirements dictate and what the builder provides, i.e. are we going direct between the PLC and the hardware, or do we need a user relay to create some sort of an intermediary connection. Okay, so let's tackle these. So what I'm going to do is I will take these 3 sequences here. This would normally be written up on the page itself, but I'm just going to do it on OneNote so I have a better maintenance of the. Actually, what I'm going to do a better maintenance of the record of what we've did. I'm going to copy each one of these individually. Thank you for the reminding of the clip. Sequence 2 and sequence 3. Alright, so as I said, from a time perspective, we would normally like till sequence 1, we would normally write this direct onto the paper. And sequence 2, and then we also have sequence 3. Okay, let me just put this up here. This is 2024 automation task C, which is say, I should write it out, automation regional qualifier task C. All right, so the way I'm going to write this one up here is that I'm going to use these out in steps. This is the first thing you do, you write in steps. Now, lights, you can put in lights in as steps, okay? So I would not do it like this, but I'm just going to show you. Right? Like I say, the first thing we're doing in sequence 1, step 10. Second thing we're doing is this counter, which is step 20. And then the third thing we're doing is the light going off, which is step 30. Right? You can do it like that, and then these are going to be intermediary steps in the counter, which is step 20. Because the lights exist at the very, very start of a sequence and the very, very end of a sequence, it's really a waste of time doing that. What I'm going to do is I'm going to turn the lights on whenever the sequence gets on and turn the lights off when the sequence is finished. And I'm just going to say that I only have one kind of major step in this sequence, which is step 10, which is my counter, and then I have individual steps in there. So this here, my counter, step 10, and then I'm going to go to step 11, step 12, step 13, which are all subsidiaries of 10, if you like. All right. Light comes on at the start of sequence 1, goes off at the end of sequence 1. Now, sequence 2, and exact same idea. Right? There's no difference. All we're doing is we're just coding a different sequence here. Right? This here is the first step in the sequence. Again, L2 and L2 on, L2 off can be treated as steps. I think it's a waste of time to do it that way. I go for 11, 12, 13. And then similarly, same vein over here. This one, the whole entire counter step is step 10, because it's the first major step. By the way, 10, I always go 10, 20, 30, 40. If you missed the building up of the template videos, that explains why. You should probably go back and have a look at them. 11, 12, and 13. So these are massively simple sequences. The awkwardness lays in how you start them, you know, and holding the button in and whatnot. But we'll have provisions, simple provisions for doing this. Okay, now what we're going to do is we're going to go on into TAA here. And what I'm going to do is I'm going to just pull this controls back over to here. I'm going to open up the template file that I created in another set of videos that are in this playlist. I have archived them into a single location. So if I go on ahead and I open up, let's browse here for automation. This was the one that I created. I'm going to delete that out. That was the one that I did archive. So I'm just going to open this up from the archive, which is in training, PLC, Siemens, and there's the archive, the ZAP file. Let's open that up. It's going to ask me where do I want to put it. I'm going to put it right in here into this automation directory. Select that folder, and that's it there. Now this is a name that doesn't make sense to what I want to call it. So what I am going to do, brave and quick, probably should have had this pre-prepared, is I'm going to close that up. I'm going to go on into that documents automation. This is this ET template video. I'm going to rename this as the 24 automation regionals task C. When I save it as, maybe it could have been a better job. Probably would have been. Let's Control C that, and I'm going to rename that again just to 8200. Apologies. Go to project. It'll be easier just to now. Project, open, browse. Yep. we'll open up this one here, project, just save it as, much easier, and I could paste that in, just copy and paste it in the automation folder, save, and that's it there. Okay, so back into this one, just to confirm what I've done there. I know I did it a wee bit quick, and there you are. So I just saved it as, this is the new one. This is the old one. This was the template video. This is the one that I extracted from the archive, and I saved it as to create that. So this is the one I'm working in here now. Okay, so the first thing I'm going to do in a task like this, if you want, we could start our timer. It is 70 minutes to do this task. I'm going to go straight into the My Data block. Program blocks, down into My Data. I have 3 different sequences. Okay, so in sequence 1, what I want to do is I want to code out here for any timers that I have. In sequence 1, I do have a timer, and that timer happens in step 12. In sequence 2, happens in step 12, and step 13 in sequence 3, but there's only one timer per sequence. So in sequence 1, timer 1, W step happens in step 12. Okay, the function in this here I don't have to change, because in my template I have them all set for 2 seconds, and 2 seconds is very common to see as a timer. 1 second and 2 seconds seem to be the most common in regional qualifiers. These are all 2 seconds, so I don't have to change any dwell times here. So I'm not even going to look into them, knowing that in my template these are all 2 seconds. That's my sequence 1 timer, and it's only timer 1 that needs to be coded. Sequence 2 timers, timer 1 also happens in step 12. And again, just for thoroughness, we could see it's already at 2 seconds by virtue of the fact that we have it in the template. In sequence 3 timer 1 happens in step 13. That's it. There's timers completely 100% coded in your whole entire project. Don't have to change them in the sequences either. All right. Now, in my sequence 1, now I need to look after my counters. So in each of the 3 seconds, my check step is step 10. This is the step there that I take the decision to say I should be going into the counter function or moving past it. Okay, so I'm in step 10. So this is going to be 10. And this one here, my increment step in each of these cases is going to be 13. So the increment means you accumulate on the registration of another count when you're on step 13. Right, so there's that, and then my reset step is going to be 0, because there isn't 2 steps that exist subsequent to the completion of the counter sub function in here. So 13s are going to be my increment step, and 10s are going to be my check step. The amount of counts is going to be 2, twice for sequence 1 and 3 for sequence 2. Now in my function here, only one counter. Let's just look at this. Our check step is going to be 10, increment step is going to be 13, reset step staying at 0, function is going to be 2. So our first one here, we only have 2 counts to do. Right? We need 3 counts for the other ones in sequence 2 and sequence 3. So sequence 2, counters, counter 1, same thing. Our check step is in 10, our increment steps in 13. However, we want to run this 3 times. So our template defaults to 2 counts. So because we have 3 counts in this one, we need to update that. So we're checking in step 10, increment in step 13, and counter 1 runs 3 times. And that's that done. Right? There's nothing else I need to do anywhere in here just now. Right? That's what you do. You set your timers and your counters first thing in the My Data block. Now, the next thing I like to do in this is I like to code the lights, because the lights can be tricky at some stage. So the lights in mine here are safety independent. This is where they belong. They always come on regardless. There's lights, and these are set up for my PB1 lights, PB2 lights, PB3, PB4, red, amber, and green. Now, I can broadly ignore them, right? So I don't even have to comment them out. There's no mistakes. Doesn't matter if they fire on or fire off. Once they're not wired and there's no lights that come on, or you don't miswire anything, you're fine. The PB1 light, right? I have 2 states for the PB1 light. It says nothing in here about blinking at 1 hertz or at any other hertz for that matter. I want the PB1 light to be on steady. So what is the condition for PB1 to be on steady? Well, my template lays it off because it's very common in regional tasks for this to be the condition for the PB1 light to be on steady, is that if it is pressed, if I do have the button pressed DI XPB1, if the input of XPB1 is true, you don't have to write is equal to true there. If you have it, then the light's on, or else it's off. So PB1 is done. That's it, that light is done. The PB2 light now, what is the condition for PB2 light to be on? Well, the PB2 light should only be on if the PB1 light is on. We know that because we said the other buttons shouldn't even function. And management run sequence is equal to 0, then that light is on true. But that's not true. In this case here, we want the PB2 light to be on. Let's just double check that I am reading this correctly. To execute a main server. Now, once activated light on, to execute a particular sequence, its associated momentary light must be pressed for 3 seconds. Once it has elapsed, the associated light will turn on and remain on until completed. Once the sequence ends, the light will also turn off. So the PB2 light, PB2 executes sequence 1, so that should only be on once sequence 1 is being executed. So if I have my push button light, if I have my dedent light on or my dedent on, if this is true, and I'm running sequence 1, then that light should be on. Or else, this is flash, there's nothing there about flashing. I'm just going to delete that out. I'll just leave it down to else it's off. So the only time it's going to be on is when I have my dedent switched on and I'm running sequence 1. If I'm running sequence 2, running sequence 3, if I'm in sequence 0, this is no longer true. So that means the light is no longer on. It's no longer true, and it will be indeed off. PB3 is going to be very similar. PBDI and running sequence 2. There's no condition here for it to flash. So I take out all that, and I'm left with that. It's on, it's true if that's the case, or else if that's not the case, it's off. And PB4 in the very same fashion, once I'm running sequence 3 and PB1, it's true. There's no condition for it to flash, or else it's off. So none of this is true. These two aren't true, and this is not true. It will be false. There's the lights done. Okay, so the next thing we'll do is we can go on ahead and we can code our outputs, right? Our other outputs, which are going to be our actuator outputs, which are our safety dependent actuators. Actuator C doesn't come in, actuator A is here. So the template that I've set up gives us if the actuator is controlled by a YA, which is solenoid actuated, SR, which is spring return DCV, which in this case it is. A is controlled by a solenoid actuated spring return valve. So the conditions for extending cylinder A and maintaining cylinder A extensions. So we're going to have to maintain these if we're in sequence A. So we could say if we're in sequence 1, A goes out in step 11 and it stays out till 13, comes back in 13. So I'm going to say if sequence 1 is greater than or equal to 11 and it's less than 13, that's it. This, I'm going to delete out this line because this is also sequence 1 condition. Right? I'll actually take out all that. Or here's a sequence 2 condition. There's two sequence 2 conditions, but I only use A and 1. If A is in 11, it's back in 13. Again, very same thing. A is out in 11, and if it's less than 13. Now what about sequence 3? There is no A in sequence 3. Right? So all that there comes out. That's A coded. So A is going to be A extend is true if sequence 1 step is greater than or equal to 11 less than 13, or sequence 2 step is greater than or equal to 11 less than 13. It's true, or else it's false. So there's A coded. Actuator B. Template gives if it's controlled by a solenoid actuated solenoid return DCV, which it is in this case. So we could say B goes out in 11 and it comes back in 13. But let's look at all the outs first. B comes out in sequence 1 11 or in sequence 3 11. Nothing for sequence 2. There is no B. Sequence 1, 11 or sequence 3, 11. So these are conditions for extended B. If sequence 1 is equal to 11 or take out this other sequence 1, all the sequence 2's, or sequence 3 is equal to 11, then B extend is true or else it's false. What's the conditions for retracting it? So this is not spring return, so we need to provide a 24-volt signal to the solenoid to retract. If we're in sequence 1, 13, nothing for sequence 2, or sequence 3, 12. So sequence 1, 13, sequence 3, 12. So sequence 1, 13, or sequence 3, step 12. B retract is true, B retract is true, B extend is false. So sequence 1, 13, sequence 3, 12. Let me just double check that. Sequence 1, 13, sequence 3, 12. That's right. That's actuator B done. You can delete out actuator C if you want. Not going to be wired, so it won't do anything. And that's all our actuators, our lights, all our outputs are now coded. Now let's code sequence 1. We don't touch the timers, they're already coded. There is some changes we need to make in our counters. There's only one counter in this, so there's counter 1 functions. I'm going to delete out just to speed up navigation and reduce a level of confusion. All references to counter 2, counter 3, counter 4. So sequence 1 counter, all of this is coded with the exception of this proxy bit. I need to change the proxy bit on this. All right. So what am I incrementing in sequence 1? Well, I'm incrementing on step 13, but I also need to make sure I have LOA and LOB. So what I need to do here is I need to add in DI dot XLOA and DI dot XLOB. That's it. That's it all done. Right, so that's the function coded. Everything else I don't need a code because I'm going to put this in here to be my reset step, which is 0 or 0. And I've already wrote in my data block as part of my first step what the preset value was for that counter. So that's done. Now the decision I need to also modify slightly. So all of this is right. If I'm up to my check step, which is 10, and I'm not complete, then I move into step 10 plus 1 is 11, which is right. Or else if I'm into this here, if I'm into my check step, which is 10, and I am complete, this says move on to 20, but there is no step 20 here. Right? There is no step 20. So what I need to do here is I need to change this to say sequence data dot X complete is true. My sequence is complete at the end of that counter. That's that done. Okay. Now I'll code up the rest of the sequence. So if I'm equal to 10 and I'm not complete and A and B are both back, which is what I want to see, then I move on into step 10. So if I'm into step 10, I get picked up here. So if my data step is equal to the check step, which is 10, it's going to either put me into 11 or it's going to finish me. So I don't need to code what to do in here, but I do need to code what happens in 11 because the counter is going to put me into 10 plus 1 is 11. So up here, I re-pick up what's happening in 11. So in 11, I get A and B both out. So I get DI. See this XL1B is what I have in as a kind of a template provision. But I'm going to put in there, if I'm in 11 and A and B both go out, then I'm going to move on to 12. If I'm equal to 12, right, 12, and there's my first timer. So I have this in a good place in my template, and the timer is complete. I move on to 13. Right, so if I'm 12 and my first timer is complete, then I move on to 13. If I'm equal to 13 and I get LOA and LOB, Then I go back, not sequence is complete, right? Because sequence complete at the end of the timer. What I do is I go back to step 10. I go back to the check step. That keeps me in a loop. And then I go back up to 10 here. What happens when you go to 10? Well, again, the counters pick it up here. If my sequence data step is equal to the check step, so I'm 10 and now I'm equal to 10. Now it says, right, it's either going to put me, if I'm not complete, you go back into 11 and you do all that again. Or else if you are 10 and you are complete, then your sequence is complete. True, it's done. So there's sequence 1 coded. Sequence 2 is going to be in a very similar thing. We don't touch the timers, they're already coded. I only have one counter in this, so just to avoid level of confusion, I'm going to take out, let me just undo that last one, I want to take all that out. And I take out these sections here. So I need to put in my increments. Take out the proxy bit, so this is sequence 2. Sequence 2, what I'm counting up off of is LOA. In step 13, I get LOA. So this proxy bit here gets changed to DI dot XLOA. That's it. And then my decision step is going to be the exact same thing on this one here. I'm either going to go when I'm at my check step, which is going to be 10, set into my data block, and I'm not complete, then I go to 10 plus 1 is 11. Or else, if I'm in 10 and I am complete, there is no 20, I say that my sequence is complete here. Then sequence data dot x sequence complete is true. That's the counter done. And then I code here. So if I'm equal to 0 and not complete, now I only need to make sure that A is back. There's no B. I'm going to take that out just in case it would be there. Then I move on into 10. The counter picks it up at 10. I need to code what happens in 11. In 11, I get A goes out. So it's L1A. And if that's the case, I move on to 12. If I'm in 12, my timer runs in 12. If the counter is complete, I move on to 13. L1A, move on to 12. If I'm into 12 and my counter is complete, I move to 13. If I'm in 13 and A retracts, I go back and LOA. Then I'm going to take myself back to 10. Like so. All right, so that's how that works. So I go to 10, I go on to 11, A extends to go to 12, I'm in 12, the counter finishes, go to 13, 13, A retracts to go back to 10, I'm up to the decision. The decision says, right, to go to 11, or is the sequence complete? And that's that one. Sequence 3, very same thing. The timers I don't touch, into the counters, only have one counter to avoid level of confusion, and then delete them out. Counter 2, 3, and 4. My proxies up here, what am I counting here? I'm counting the timer, the queue complete. This is what is going to be is going to say that the increment is finished. So it's not the proxy bit. What I'm counting in here is in my sequence data dot timers dot, it's timer 1 that I'm counting, dot function dot queue. Function dot queue. So I need that to complete the prerequisite amount of times. So that's it done. The decision. So if I'm in my count step and I'm not complete, then I go until step 11, which makes sense. If I'm in 10 and this has not been done 3 times, I go to 11. However, if I have been done, then sequence data X complete is true. That's done. There's the counters done. Now, my progression. So I just need to make sure that B is back here. So I'm going to take out a fraction to A. So if I'm equal to 0 and I'm not complete and B is back, then go on until 10. That will let my counter decide, do I go to sequence complete or do I go to 11? In the eventuality, it puts me into 11. What I should see here is that B extends. I get L1B, right? And that's going to put me on to 12. Now, if I get into 12 here, I should be sending B back, right? So what I'm going to do here is I'm going to just take this else if, and I'm going to paste it in here and say if I'm equal to 12 and I get LOB and put me on into 13. Now, why did I bother instead of changing something here? Because I have my counter function here. So instead of having to rewrite all that out again up down here, because I've overwrit that to get 12 in, I've just took a convenient copy and paste where I only had to make a couple of changes, and I've retained this here for step 13. Right, so if the counter function is then complete, then I want to go back to 10 and check to see have I done it enough times. So that goes back then to 10. That's it. And then I'm at the step 10, and all that there comes out. So there's sequence 3 complete. Now the very last thing I need to code is my management. Right? So the timers, I have no counters in here. I'm just going to delete them out for convenience, but I do have timers. Actually, I have 3 timers. So management timer 1 function, so the proxy bit. So my first timer, the input here is going to be my management dot timers dot timer 1 function. No, apologies. It's going to be di. I was getting ahead of myself. Di dot xpb2. That's what I'm timing. And I'm going to time that there. I have to go back into my data here and program these timers. Apologies. I need to time PB2 for this amount of time. That's going to be my first timer. That's my first button, because recall I need to hold in the button for 3 seconds and then the sequence is to start. So this second one, function 2, I'm going to hold in PB3 for the amount of seconds that's programmed here for function 2. And then I need to also do this for the third timer. Timer function 3, TON is PB4, that's timer function 3. Right, so before I go on too far, I'm going to go back into my data. I should have did this at the very start when I was here. My management, my timers, timer function 1. Now preset time is I need to hold this on for 3 seconds. Preset time, 3 seconds. Timer 3, preset time for 3 seconds. Now, yeah, I could have just wrote that. I could have just wrote that here, PTT is equal to 3 seconds, but the thing about it is that if I was doing this on Node-RED or some other sort of interface, I could get into that data block and I could change that 3 seconds in the data block to 4 seconds or 2 seconds or whatever. If I wrote 3 seconds or 4 seconds here, I could not change that on a different terminal. I would need access onto this into this function, which I wouldn't have other than on this workstation here. But writing it into my data and asking the code to monitor the data at that address or in that block gets us around that. So safe status. So if the system is safe, then we have all that. Now, at the minute, it's going to be unsafe, right? Because I do not have DI eStop and DI SLC, safety light curtain. We don't have that in here at the minute. So what I'm going to do in here is I'm going to write in, I'm going to say that DI dot eStop is true. Right, I'm just going to write them in here to be true. DI dot safety light curtain is true. Right, I'm just going to write them in as being true here. So I'm effectively going to overwrite them. Now you can write them there. The problem sometimes it's going to come up in that CP interface. CP interface is saying here that your input, CDI, stop and SCL is going to do what the input says there on if they see an input coming in or not. If it doesn't see it coming in, that's going to kick yourself back into false there. It's going to say no, it's not true. You're going to have a conflict there. I don't recommend always doing this here, right? Because it footers with the template and something there that could catch you out later on. But if you know what you're doing, you can. Or the most solid way of doing this is just providing a 24-volt signal into that input directly from the 24-volt power rail. But what I can do here as well is just indicate that these are true here. Right, so not taking in a signal from the outside world, because we do not have an e-stop wired and we do not have a safety light curtain wired, so these are going to be low. We're going to have low false signals in this, and it's going to put us into the unsafe mode. I'm going to write them in as being true. Now the other argument says, why bother putting a safe mode into the regional task? Well, yeah, that is a good argument. I haven't seen an e-stop on it just yet, but who knows? Right? It may be something we would all welcome very much, to seeing an e-stop into the regionals. Would be good prep there for the national finals, in which they're always there, and even the light curtains for the last couple of years. So back into the management block here again, apologies. If that's the case, we don't even need them there, but I'm going to leave them there just as a reminder that I have changed it in case for some reason I reuse this template, or I save this template, or I don't take the blank template, which I should in every case. I'm just going to leave them there as reminders. So at the minute, I should see that this system is safe, and that should give me access then into my outputs. First scan is fine. What happens at first scan? I'm going to reset everything. Now my initial conditions, so if run sequence is equal to 0, I want to make sure that all my extensions are false and my retractions are true, so my cylinders will be held back in step 0, sequence 0. So code my 3 number sequences. So at the end of the sequence, so when I get, if I'm in running sequence 1 and it's complete, I'm going to put everything back. That's all dead on. How do I start the sequence, right? So this is the thing here. This is the funny thing about the modes and this and that, right? So if management run mode is equal to 1 and I'm not running a sequence, right, then go into run sequence 1. So the way this is written is that run a sequence 1 depends on the mode being into 1. So what I'm going to do is I'm going to use the buttons to turn to indicate the mode, and then when that mode hits 1, I'm going to run the corresponding sequence. Right, so there's nothing to change on these sequences, right? Run sequence 2 if sequence 2 is at the end, if I'm running sequence 2 and it's complete, just put everything back to 0, reset everything, you're finished, you're done. How do I start it? Well, if the mode is 2, then you're running sequence 2. The same thing with sequence 3. Let's just double check, just cast an eye over it. At the end, if I'm in sequence 3 and sequence 3 is now completed, put everything back to scratch. How do you start the sequence? Well, if I'm in mode 3, then run that. Great, so the modes are going to be the ones. So how do you start a mode? Well, if I'm into management road is equal to 0, right, I need to be in 0. I need to make sure that the push button, that the DDANT is also operating as a condition. So I'm going to put in DIXXPB1. I need that in all cases. So I should not be able to execute any of these unless that push button is pressed. So if I'm in 0 and I have the press button, and not that I press PB2, because PB2 is going to be pressed up here in timer 1. PB2 needs to be pressed there for 3 times. So what I'm going to do is I'm going to take a copy of this function and saying that if I'm in 0 and I have my DDANT in and function 1.q and my timer has completed, i.e. it's been held in for 3 seconds or the prerequisite amount of time, then run mode 1. And then what's going to happen up here is we're going to see if I'm in run mode 1, which I am, and I'm not running any sequences, which I'm not, then run sequence 1, and then I'll execute sequence 1. So same thing here with run mode 2. Right, I'm just I'll copy that. So I'll actually copy the 2 lines here, Control C. So if I'm in run mode 0 and I have my moment or my dedent button and I run my second timer, then go ahead and run mode 3 or mode 2, apologies. And for mode 3, exact same thing. I'm going to say if I'm in run mode 0 and I have my dedent button and I run my third timer. Again, the third timer is this one, which is holding in PB4, my third momentary button, for the prerequisite amount of time as defined in my data block. Then what's going to happen is I'm going to run mode 3. And if I run mode 3, so there's sequences. If I say that I'm going to run mode 3 here, which I have tied to sequence 3. If I'm in mode 3 and I'm not running any sequence, well, congratulations, now you're running sequence 3. And that'll execute. All right, once all them changes are made, let's go down into that. We'll go on to the main block. Just make sure that you don't have any big X's here that are completely obvious. Click onto your Sean's PLC or your PLC name, hit compile. Make sure you have no errors, no warnings. Probably will have the 3 warnings there, which you will the very first time you do this, which is again saying that you have an OPC UA server opened up and you don't have an encrypted password or there's no levels of protection against it. But as was the case with the template, every subsequent compilation that you carry out on this code, you will not see that error. So just to put your mind at ease, let's just shoot up to where the errors are. There you are, configured protection level. UA server, permitted unsecured communication, access without user authentication. There are your 3 errors. All right, so they won't stop the code executing. We know them. They're acceptable for us, knowing that we're not dealing with any hugely sensitive information. So when that's done there, you can save that up. Let me see here. I actually have a Ethernet connection. Again, I get this onto my PLC to the back. Let's give it a second to register on that network. You can download that down into your PLC. I don't have the hardware set up behind me for this, so we're not going to execute it, but I just want to make sure it goes down into the PLC. There it is, load. Us reinitialize on and load. Finish. Right, that's it done. So that should allow your PLC code to execute. I'm not sure how long that section took. There's a lot of explanations in it, and there's this and that. But if you're doing that maybe at competition speed, you can do it fairly quick. And that was 2024, so it's a very contemporary, very recent competition qualifier. I will do other ones as well in subsequent videos. Last year's why I didn't do 25 was that there was additional hardware provided, which I might just do, but there's a wee bit of extra explanations on that. There was a separate push button given. There was a good bit of hardwiring to be done by the builder, and then the outputs of that hardware kind of DIN rail mounted arrangement was brought up into the PLC. So yeah, I'm absolutely going to do that, but I wanted to run through a couple of the templates just using kind of descriptions that you yourself might be able to get from previous WorldSkills tasks at this level and be able to follow along with it, because at least everybody's familiar with the TP 101 and 201. If indeed you are competing at this level, you would be. So I thought that might be helpful, but I'd be confident there that with that onto the PLC now, if I had that wired up and I had the hardware configured in the way that's laid out in that task, everything would work just fine. yeah, so I'm going to finish up the video with that, and want to thank you, of course, as always, for joining me. Hit the subscribe button, because if you do that, then the next time I put up a solution to a previous regional task as part of this series, you get notification of that. So what I will do is I'll go on back and I'll do 2022 and 21-23. Of course, there was years there maybe in COVID that they weren't in 2019. I believe it was a particularly challenging one. Not so much challenging, but a little bit of thinking, because we had two nested counters in a larger counter. So when I tackle them videos, when they are finished, if you are subscribed, then obviously you will get a notification that they're available. Regional qualifiers tend to be in June, yeah, a couple of months to go. Get ready for it, and yeah, I wish you all the luck, best of luck. If you have any questions, if something's not working, if something's unclear, if you have a suggestion on how you might do something a wee bit different, always interested in hearing, always interested in improving, modifying, adapting, and finding better ways. So yeah, let me know, and thanks again. See you in the next video.